Then now let's continue. Let's continue with the module 12. That here in the earlier one we are seeing the movements of flagellum, undulatory movements of flagellum we are seeing. Okay, so here the ciliary movements and flagellary movements. What do you call them as sidewise lash movements and sidewise lash movement. In both flagellum and cilium, you can see this kind of sidewise lash movement. In sidewise lash movements, there are two phases. One is effective stroke or recovery stroke. Effective stroke are also called repulsive stroke. And the next one is a recovery stroke. Recovery stroke. So let us see how it is. Either it is flagellum or cilium. Both is going to show this type of locomotion. As I already shown you that flagellum, a type, they show undulatory movements of the flagellum. And next, the second type of movement we are talking in the flagellum, that is sidewise lash movement. Here in this case, the flagellum becomes rigid and start bending to one side, beating against the water, which is at right angles to the body axis, and the organism move forward. So nothing complicated here. Simple to say, very simple to say that is swimming. A person, when he is in the water, what he will do with his hand? So he just makes the water to be move backward and he moves forward, isn't it? A swimmer, a basic swimmer even know. So that what he is saying, flagellum becomes rigid. This is the flagellum. This is the flagellum. Flagellum becomes rigid and start bending to one side like this, beating against the water. So just beating against the water at right angles. I think you recognize this right angle. Right angles to the whom? Right angles to the body axis. So I'll show the body axis. This is the body axis. The right angles to the body axis. So this is the red one I am showing, the body axis. So right angles to the body axis, 90 degrees angle. We are saying right angle. Okay. So then organism moves forward, not like earlier, not like earlier. In earlier case, what we said, flagellum show undulation movement from the base to tip or tip to base. But here, in this case, that what we are saying in this case, the flagellum becomes rigid. The first flagellum is going to be rigid. Okay, so the flagellum becomes rigid. Then the beating the water, the beating again is the water, which is at right angles to the body axis, and the organism moves forward. So what do you call this stage? Effective stroke or propulsive stroke. This is the effective stroke. Okay. So it requires energy, isn't it? That means beating water again is that means that definitely require energy. Beating against the water is require energy definitely. So what next? What next? Recovery stroke. Recovery. So just see the power stroke. That is actually the cilia in the photograph. But now I shown to you how the flagellum show. Now the flagellum becomes soft. Here I am showing again in euglena. Here is the position, isn't it? This is the position. Now the flagellum becomes soft and will come back and will become straight. That means like this. So what do you say is as recovery stroke? Flagellum becomes soft and moves backward to its original position. A basic swimmer even know while pushing the water, beating against the water, that we show power and we'll take our hand, relaxed mode, we'll take our hand back. What do you say that as recovery stroke? It doesn't require energy. So at least you just don't go through these two diagrams here. That is ciliary effective and ciliary recovery stroke. As I already shown to you, flagellary effective. I'll show you once again. Let's talk about flagellary effective stroke and flagellary recovery stroke. So this is the euglena. Okay, this is the euglena directly, and a euglena I'm showing here for you. So then let's talk about the flagellum. As I said, flagellum becomes rigid during the time of locomotion. So it beats against the water, right angles like this. So what we said, right angles to the longitudinal axis of the body. So this is the longitudinal axis of the body. So right angles to the longitudinal axis of the body, that organism moves forward. So what do you call this as? Effective stroke. This is called as effective stroke. Okay. So what next? What next? Recovery stroke. That means flagellum need to becomes relaxed mode and need to get back again to the original position. So what do you say it as? Recovery stroke. This is called recovery stroke. Effective stroke require energy, but not recovery stroke. Effective stroke makes the organism to move the forward. Okay. So then that what do you say? Effective stroke of flagellum. Okay. So we are just discussing about the flagellum only. After that, we'll go with the cilium. As I already said to you about the undulation movements of the flagellum. That is different from here. Okay, so people, you should not confuse in between. Some people, some students will come and ask, like, sir, you said flagellum becomes wave-like movement. Flagellum show undulation. Then how can you say flagellum becomes rigid? They'll ask for. That's why from the beginning I am differentiating. That is a type of locomotion. That's why I said over. A person A can walk, can run, can jump. So his movements we are talking about. Likewise, a flagella, sometimes it may show undulatory movements and sometimes it may show sidewise lash movement. What do you say this as? This is called sidewise lash movements. These kind of movements are called sidewise lash movements. Okay. So these sidewise lash movements, the first one is effective stroke and second one is recovery stroke. Effective stroke to make the organism move forward, and recovery stroke to show another effective stroke it will be helpful for. Okay. So then now let's move to the movement of cilium, the two movement of cilium. So how does the ciliary movement occur? So there is a difference between the flagellary movement and ciliary movement. You may have seen over the cilia are present all over the body surface, isn't it? Okay, so the ciliary movement is comparatively little different. Let me show you one cilium. One cilium. Okay, so clearing everything. Then after, so this is the paramecium. In paramecium, that how does a cilium show? That effective, same effective and recovery, but there is a difference. There we are seen in case of flagellum, that is 90 degrees angle, but here you see the 180 degrees angle, 180 degrees angle. So this is the cilium. Cilium moves the water the parallel to the surface of its attachment. The full effective stroke we can see. So that here half we are seen in case that in case of flagellum. That means more powerful stroke we can see. Okay, so for that, what is the description? Let us see here. Let us watch. So this is the flagellary locomotion. The first, well, let me complete the flagellary locomotion. Then after, when we go to the ciliary locomotion, I will make you to differentiate. But you remember that in case of flagellary locomotion, that effective stroke is going to be the perpendicular to the longitudinal axis of the body. When it comes to the ciliary stroke, which is more effective, parallel 180 degrees. Here, if you see 90 degrees, if they are here, it is going to be 180 degrees. So you just try to find out that difference. Then after we'll go to the ciliary locomotion. But let me complete that flagellary locomotion first of all. Here, as we said, there are three types of movements in the flagellum. And we that first one, we are seeing undulatory movements of flagellum. Then after, the sidewise lash movements of the flagellum. And now we are moving toward the simple conical gyration movements of the flagellum. So now need to say there you can see the conical gyration movements of the flagellum. Flagellum turns like a screw. In this case, flagellum turns like a screw. You just imagine, turns like a screw. That exerts the propelling action, pulling force that pulls the organism forward through the water. You may have seen the drilling machine actually, which makes the holes in the wall. So that what do you say? That is exact screw. That our animation may not supporting completely. That it seems to be like undulation, isn't it? That is kind of. So, but you just understand if by making comparison with the turns like screw means the making hole that a particular mission. You just imagine in that point of view that you can understand. Here, more turning is not possible for us to create in animation way. So just remember it turns like a screw. Okay, what happens if it turns like a screw? That organism, it pulls the organism forward through the water. So what kind of action it is? Propelling action and pulling force, we say. So with a spiral rotation around the axis of the movement and gyration on its own axis, that means that euglena, that with spiral rotation like this it will move, then rotating themselves, it will move. So let me show you, so like this, the flagellum turns like a screw. Okay, so even I can't make it screw like that much faster, but you can see that he is making holes that will turn like a screw. So what he is saying, gyration in its own axis, how it moves, it pulls the organism forward, spiral rotation, organism spirally rotates by rotating themselves. Okay, so that gyration in its own axis, it moves spirally. The organism is moving spirally, but at the time when it is moving, it is rotating their own axis on their own axis. Okay, so you may understand that complicated issues of Earth. The Earth will move around the sun, and also it rotates on their own axis. That you people are much perfect that in that area. So imagine in that way that you can understand. Okay, so no way this animation will not be much helpful for us. Okay, then let's continue here. The simple conical gyration movements. What we need to understand in simple conical gyration movement, you need to understand the very important thing here. So whether we got answers for our questions like that or not. So like flagellum turns like a screw in simple conical gyration movement. Flagellum turns like screw. What is the action? Propelling action. What is the force? Pulling force. How where the organism move? Organism move forward. How it moves? Spirally rotates. By rotating on their own axis, it spirally it moves. It won't go straight. It will go spiral like this. So that you need to understand. This is about the flagellary locomotion. We just talked about the flagellary locomotion. Okay. So that let me give a brief what we did actually, what we did in the case of flagellary locomotion. That is very important for us because the full clarity we need to have. I said the movement of flagellum is of three types. Movement of flagellum is of three types. Is three types. Okay, what are the three types? Number one,
Undulation.
let me show you the first one. What is the first one we are seeing? Undulatory movements of flagellum. Undulatory movements of flagellum. Giving a glance look on the total, what we learned till the time. Undulatory movements of flagellum. Okay, next, second one. What is the second one? Sidewise lash
Sidewise.
movements of flagellum. Sidewise lash movements of flagellum. And the third one. So what we said about the third one, now we said learn that simple conical gyration movement. Simple conical gyration movements of flagellum. These are the basic things we learned. In the undulatory movements of flagellum, when we talk about the undulatory movements of flagellum, what we say that undulations may be from the base to tip or tip to base. That undulations when it occurs from the base to tip. Here we learned three issues: base to tip, and that second one is the first one, and the
Tip to
second one
base.
tip to base, and the third one bend and base to tip. We have seen so many, but when it comes to the textbook, we have three: bend and base to tip. Okay, so bend and base to tip. We have seen the three. Okay, so then let me write this clearly. The three issues we have seen. 1, 2, 3. So 3 issues. Only 3. But I may have shown to you bend towards the right, bend towards the left, all the things. But only 3. That whatever there in text. It's a base to tip. And the second one, tip to base. Let me slide this. It is giving some problem. Tip to base. And the third one, bend end base to tip. So just that 3 we are seeing. Okay. Next, in the sidewise lash movements of flagellum. In the sidewise lash movements, we are seeing the 2 issues here. Number 1 and number 2. Number 1, effective stroke. Isn't it? Effective stroke. Okay, next number 2, recovery stroke. That is in case of sidewise lash movements of the flagellum, we are seeing effective stroke and recovery stroke. In simple conical gyration movement, we said that flagellum turns like a screw, and by rotating on their own axis, that euglena show the spiral rotation. This is the movement of flagellum. There are 3 types of movements are there for the flagellum. This is a little complicated, so I think we are completed and we are able to understand this particular movement of flagellum. Then the next class, manam will move towards the celiac